Today, we're joined by Lindsey Bartolomei from the city of Rochester. Lindsey, thank you for joining us. Why don't you talk to us a little bit about what you do and what you do inside of the city?
Good morning, Mike. Thank you for having me. I'm really happy to have this opportunity to talk to you today. Well, I'm a water resources engineer for the Department of Public Works at the city of Rochester. As the water resources engineer for the Department of Public Works, I help the city manage stormwater and surface water within the city boundaries, and I also review construction plans for new development projects taking place in the city of Rochester for compliance with our stormwater management regulations and standards.
So talk to us a little bit about what you do from a looking at development standpoint. I just find that to be pretty interesting, that's something that a lot of people wouldn't think about. The fact that as a development gets created, you need to go through the process of working with water and stormwater. Can you talk about that a little bit?
Yeah, absolutely. And it is a long process to go from, say, a vacant piece of property in the city to a commercial business, for example. A developer, a private developer, has to go through a long process and talk to a lot of different entities. Stormwater is one of them. And some cities are regulated by a different entity, like a watershed. Oh, what are they called? There's a different entity besides the Public Works Department, but in the city of Rochester, it's the Public Works Department that that does the stormwater part of the development process. So yeah, when you put a new building or a structure or do any sort of regrading or modifying of an existing piece of property, you have to make sure that you're not going to impact your neighbors. You have to make sure that you're not going to generate a quantity of stormwater that the public infrastructure can't handle. You don't want to cause any flooding for yourself or your neighbors. And also what happens when you change grass, like a grass surface, to a concrete surface or a bituminous roadway or a parking lot or building roof, you end up generating more pollution that goes into that stormwater than was being generated by the stormwater when it just landed on grass. So as the entity responsible for managing the quality of that stormwater, we have to work with the design engineer on that project to make sure that they're doing something to manage the pollution that they're adding as a consequence of that development. So I do work very closely with consulting engineers, and these are professional engineers just like me, and they just happen to work for a private consulting firm instead of working for a regulatory department or a city like I do. So they will design a pipe system, or they will design a series of inlets, or what we call in the field a BMP, a best management practice, to treat the stormwater before it goes into the public pipe system and then goes to whatever the receiving water is, whether it's a pond or a lake or a nearby river or stream. So that's how they manage their pollution. And so what I do when I review those plans is make sure that they're doing that properly and that they're meeting the goals that we need them to meet.
Excellent. So obviously there's a lot that's required to do the work that you're doing. What made you decide to go into this field, and is this your first job out of school?
No, I took a long roundabout way of getting here. I went to school twice. The first time I went to school for environmental and forest biology, which I loved the program, and I got out with a Bachelor of Science degree in biology, and I worked for some environmental testing labs. I've always been geared towards environmental work. So I've always worked in the environment in some way. So then after I got I put a few years into working with my biology degree. I decided that I wanted to do something else. And the main reason for that was financial security. I thought I could probably make some more money in the long run or in the short run as an engineer than I could as a person with a biology degree. And so I was kind of looking for something else to do anyway. And so I decided to go back to school. And when I went back to school, I lived in New York at the time. So that's where I was educated. I went to the State University of New York College at Buffalo. So for short, it's called the University at Buffalo. And I got my environmental engineering degree there through their environmental engineering program in Buffalo. And then as I was doing that, I also joined the National Guard and I went through the Army ROTC program, which was really valuable for gaining leadership experience, but it also got me accepted into an internship program with the Army Corps of Engineers. So right out of my engineering school, I graduated in 2012. I went to work for the Army Corps of Engineers. I spent a couple years with the Army Corps of Engineers, and then my boyfriend at the time, now husband, got offered a job in Minnesota. And so together we moved from New York to Minnesota, and I got a job with a private consulting, a private kind of construction company. And I did agricultural drainage, and I worked on some other types of like directional drilling projects and drainage, more in the ag field, field, I guess. So then after that, I went to a private engineering consulting firm here locally in Rochester. And I got to work with all of the regulations and standards and all of the design standards that I am now working to enforce as since I've joined the Public Works Department in the City of Rochester. So I spent a couple years as a private consultant, and then about 2 years ago, I came to the Public Works Department. So I had, as I was working as a private consultant, I had some thoughts about things that I thought would make my life easier and things that I thought would help protect the environment better. So I had a lot of conversations with the people that the people who were in my position now. I got to talk to them a lot because as part of the development process, the private design consultants have to talk to the regulators and make sure that you're doing it all, accordingly. So I had a lot of experience with the work that I'm doing now. So when this job position came open, I thought that it would have been a good fit for me. So I applied, and I'm really lucky to have found myself here working for the Public Works Department. Now I'm kind of on the other side, working with those private consultants, kind of working with those people who were doing what I was doing just a couple of years ago.
Thanks for that answer, Lindsey. And tell us a little bit about the technical skills that are required to do the work that you do.
The technical skills that are required to do the work that I do, let's say to be an engineer, or to be like a water resources engineer, or an engineer in the environmental or civil fields. The technical skills that you need are data analysis. You have to be able to, you got to have analytical skills. You got to have problem solving skills, detecting patterns, brainstorming, theorizing. These are interpreting data, and one of the most important things, integrating new information. So when you learn something new, you got to be curious, and you gotta want to solve problems, and you can use many different tools to solve many different problems. But once you figure something out, use that then in your future. So integrating new information into your thought process, into your work process, really is the thing that's going to allow you to excel ahead of those who don't practice that as well. So and technical skills are something that develop over time. So in what I found in my experience is that I had kind of a natural ability to be a problem solver. I've always had kind of a natural technical mindset. But, you know, technical skills aren't something that you're born with. You might be born with a certain way of thinking or a certain way of doing things, but you develop that over time by practicing and by incorporating new knowledge. Every time you learn something new, you use that as a tool to then learn more new things. So it's a positive feedback loop.
So let's talk a little bit about what students would have to do to kind of go down the path that you're talking about. And I'm not just talking about the engineering path here. I'm talking about how you kind of work to develop those problem solving skills that you were talking about there.
That's a tough question because it's going to be different for everybody. It depends on what your strengths are, and everybody's strengths are different. But I think that the best thing to do is to be curious. Be mindful of your curiosity. Think about what you're thinking about. If you observe something that you think isn't working, something in the physical world that isn't functioning properly, something is failing, or, you know, anything that you observe that you think can be better, brainstorm. Think of ways that they could be better. Write things down. Keep a journal and kind of write, especially if you are going the engineering route, because for practical purposes, if you want to become a professional engineer, you have to document your experience. So keep a journal and write down the things that you're doing. Write down the projects that you're working on. Write down what went right, what went wrong, and, you know, the things that, did you meet your goal? How could you have done it better the next time? And then use tools, use technology. I use Excel every day to build models, to solve math problems, to plot out trend lines, just to visualize what data looks like. Excel will never fail you if you develop those skills at solving problems, because you might not be able to rearrange an equation, because once you get into some engineering equations are written, they're hard to rearrange, but you know some variables and you need to know another one, and the one that you need happens to be in the denominator of an exponent or something, and it's difficult to rearrange it to solve for that. You can use Excel to do that. So, but you know, start small and use Excel for things, and then learn it as you go. And then the more you learn it, the more you do it, the more you use it, and then the more you can realize what you can use it for. So I think, I think that the general process here is to just be mindful of what you're thinking about, try to solve problems, and then, you know, write things down so that you can look at where you were before and use that information to try something new in the future.
Excellent. So with students, if they were, what would you suggest that students take in high school to progress into what you're doing now?
Math. Take math courses, but don't get overwhelmed with it, because you have to learn the material. So if you're getting frustrated with the level of math you're at, don't take a more advanced level just to get it done before you go to college. Or, you know, like in my case, I just took the math classes in high school that they told me I had to take. And when I got to 11th grade, I actually had a choice of what math class I wanted to take as a senior. And I decided to take the easiest math class that they offered. And my teacher in 11th grade told me that I shouldn't be doing that because I was too good at math to kind of take the easy route. And I was like, well, geez, I wish you would have told me that earlier. I would have felt, would have felt good to know that my math teacher thought I was good at math. But besides that, what I wanted to do was give myself a bit of a break before college, because I knew I would be going and taking math in college, and I wanted to kind of relax a little bit as a senior in high school. So take math, take science, take physics. You want to learn the fundamental basics of why things are the way they are. The fundamental basics of forces, of energy, of states of matter, of rocks and soils and atmosphere, and, the fundamental basics of why the earth works the way it does. But if you find yourself getting frustrated, take a step back and learn the material that you have to know in order to advance. Because if you don't learn the basic stuff, the more you advance, the harder it's going to be. So when you're doing your homework, make sure you're paying attention to it and you're actually starting to understand what it all means. And that is the best thing that will help prepare you for going into kind of a more technical field like engineering. Other things that I would highly suggest in high school are economics, because you want to start laying the groundwork for things like project management and budgeting. I would suggest taking, there was one that I wanted to tell you, leadership and professional development. If you can take anything geared toward leadership courses, which might not be offered in high school, you might get there in college, but those are really important. You start to learn how to interact with your peers in a way that inspires followers. That's valuable. That's a valuable skill, and it's a valuable personality trait, and it's something that will serve you very well in your career, no matter what career you go into.
So, kind of springboarding off that, what other kind of soft skills besides leadership would you suggest that people need in order to progress in their career?
Soft skills are really important in your career and also just in life in general. And the cornerstones that I would recommend to anybody, and things that I pay attention to and use in my own life, are big ones: honesty, integrity, reliability, and ask lots of questions. So the way I would define, honesty is pretty self-explanatory. Be honest with yourself, be honest with the people around you. Say things as you observe them, not as you wished you had observed them. Integrity, I would define it as doing the right thing even when nobody's looking. Just maintaining that integrity reinforces honesty, and it inspires trust. So other people will know that you did what you said you did, because that's your personality trait. You are usually honest. That's something that's going to take you far. And ask lots of questions. Don't be afraid to ask questions. Don't be afraid of failure. Failure is not failure. Failure is an opportunity to learn something new. When you learn something new, it goes back to integrating it. When you learn something new, integrate that into your actions and your work in the future. Always hold yourself accountable. So hold yourself accountable for your actions, for your decisions, and for your comments. So if you hold yourself accountable, you will set a positive example for those around you. People will learn that they can trust you, and you will gain confidence in yourself, because just if you do something that turns out to be a mistake and it causes a problem in the future, in my case, maybe we go over budget, or maybe I miss a deadline, or maybe I recommended somebody do something that actually turned out to be something that is not acceptable. That was a mistake. I didn't mean to do that. I didn't foresee it that way, but now I know. Apologize if you need to, and move on. Leave it in the past, learn from it, and move forward.
Excellent. So let's talk a little bit more about your college career. What degrees you went to, and uh, why why you chose to get that secondary degree besides the monetary aspect of it.
Yeah, I took kind of a roundabout way with my education, but I guess I'll keep it as short as I can. I went to college right after high school because at the time I just wanted to leave home. So I knew, plus I was pretty good at school, and I wasn't gonna, I just always knew that I was gonna go to college. So I went to college right after high school. I got my 4-year degree in biology. I worked in the field for a while, and then I don't know, I wanted something else. I wasn't quite satisfied with my career, with where I was in life. And so I had the opportunity to go back to school, and the way I paid for that was through the Army scholarship. So it was a lot of work for me to go back to school for engineering, but I thought it would be worth it in the end, and it turns out it definitely was. I think when I originally went back to school at the University at Buffalo for engineering, I knew I was going to be going for engineering, but I started originally as in the electrical engineering program, which was completely different from anything that I had done in the past. But when I was researching potential military careers, something along the electrical lines kind of interested me. And when I was in high school, I had the opportunity to go to a technical afternoon program for robotics, electronics and robotics. And I somehow let my dad talk me out of it. And I wish to this day I hadn't. I wish to this day that I had taken that electronics and robotics course in, I think it would have been junior and senior year, or maybe it would have just been the afternoons in senior year of high school. So I always kind of regretted that. So I think when I went back to school for engineering, the electrical engineering program kind of satisfied that. But I got into it. I spent 2 semesters and I didn't do very well. I didn't do well in circuits. It was really challenging for me. And I didn't have the kind of support system with my peers as I had when I went to school the first time, because I was older now. I was 26 when I went back in a bachelor's program. I went back through a 4-year bachelor's program where most of the students then were, it was their first time right out of high school. So that was different for me. And anyway, then I discovered that school had an environmental engineering program. And I was like, oh, this is much more in my zone, much more suitable to my personality and my past education. Because even though I went back to school, I mean, everything I learned in my environmental biology program, I was able to apply forward in my engineering program. I learned about ecology, and I learned about, using math to define problems and to solve problems in the real world. And so that all was reinforced with my engineering degree, with my engineering program. And then let's see, so as I got through the engineering program, I worked really hard. It took me a long time to do my homework. I went for extra help. I spent office hours at the teacher's assistant's office. But all of that is what I needed to do to really learn the material. And I did, and then, so it made it easier as I went on. Let's see, so after that, I totally lost my train of thought. The engineering, I totally lost my train of thought. Where was I going with this? So, oh man, can you repeat your question again? So what do students have to do to follow, to kind of do what I'm doing, right? How do they have to go?
Just talk about kind of how you ended up where you were. Yeah,
I wanted to talk about the FE. So okay, when you're in an engineering program, and if you want to go to into an engineering degree profession, if you want to become an engineer, you can decide whether you want to become a professional engineer or not. And then when you're in your engineering program, make sure that you go to school for an ABET accredited program. So when you're in high school and you're researching your colleges that you want to go to, if you want to go engineering, make sure that you go to a school that has an ABET accredited program, because that's the only path towards becoming a professional engineer. You don't have to become a professional engineer, but if you decide in the future that you want to become a professional engineer and you didn't go through an ABET accredited engineering program, you're going to have to do it again. So towards the end of that program, you'll have the opportunity to take the fundamentals of engineering exam. And I would recommend to anybody, even if you know for a fact that you're not going to become a professional engineer, take the fundamentals of engineering exam, because you never know what's going to change in your life that's going to make that a more viable pathway for you. If you decide that you want to become a professional engineer, you'll already have that fundamentals of engineering exam done. So take the fundamentals of engineering exam. You're going to have to study for it. It is a big deal, but you'll do it. You'll do it the first time, you'll get it done, and then you'll have the opportunity to document your experience and then apply for the PE exam if you want to. If you don't want to, no harm done. You took the fundamentals exam just for fun. But that's the way to do it. So then if you want to become a professional engineer, keep a notebook, read your state's requirements while you're in high school or while you're in your engineering program. If you live in the state of Minnesota, go to the Licensing Board of Minnesota's website and read the requirements for applying for the PE exam. And then keep yourself a notebook and write down everything. And this is going to be over the course of four or 5 years. Write down everything that you're doing, all of your experiences, and write it down in such a way that you're following the requirements for that exam that board says you have to do, because the application process is complicated, and you're going to be much better off if you had taken all those notes during the course of those years than if you're thinking back 4 years ago, thinking about who your supervisor was, how much time did you spend doing that project, what's the contact information for your supervisor. You're going to need to gather all this information as you go. So then if you decide to, you can apply for the PE exam, and when you pass it, you become a licensed professional engineer. And that is something to be proud of.
So let's talk a little bit more about your journey, because I don't want to miss this fact. You talked a little bit about your military service and what you did. Talk about that, how that influenced what you're doing now.
Sure. Yeah, so it was about 2009 or 2010, I joined the Army National Guard. I also was going through the ROTC, an Army ROTC program at the college I was attending at the time, SUNY Buffalo. And so it made for a really, really busy 3 or 4 years, because I was doing, the ROTC requires physical fitness in the morning. So you meet up with all of your ROTC people early in the morning at like 4:30 or 5 o'clock. And then you do your workouts for the day. And then you also have classes, you also have labs, and you also have drills on the weekends. And then for me, I was also in the National Guard, so I was also drilling on National Guard weekends too. So sometimes 2 weekends a month would be Army stuff, and I wouldn't have time to study for exams or do homework during those weekends. So I gained valuable experience in management at that time, at that time, and also personal growth in staying calm and kind of managing my emotions so that I stayed even keeled and able to learn and accomplish all the things that were required of me at the time without getting flustered or angry or, it was very difficult, but it was a valuable learning experience. So after school, the ROTC program taught me a lot about leadership. That's the whole premise of the program. You're becoming an officer in the military, and being an officer in the military is all about leading troops, leading other people. You're the decision maker, you're the planner, you're the person who has to line up the resources and make sure that your people, your troops, have the training that they need so that when they get called into battle, they are well equipped. So that's a big deal. If you don't take that leadership seriously, you won't be taken seriously as a leader, and you're not helping the people who you're supposed to be leading. So for me, it took a long time for that leadership training to sink in. I didn't get it at first. It was hard to use. It was hard to use at the same time I was learning it. But the farther I am removed from it, and the more time I spend in my engineering career, any career, the more I recognize the leadership lessons that I learned through the military, and I'm able to apply those in my personal career over time as I move forward. So I feel that I have a good understanding of how to inspire people to follow me. I understand the value of honesty and integrity. I understand that making a plan is extremely important. Having a goal is important, but you can say your goal all you want. If you don't take the time to make the plan to get you and whoever you want to follow you from where you are now to where you want to be, you will not get there, and you won't bring the people along with you either. So, and making that plan is a skill. It's a technical skill, an analytical skill. It's a soft skill that is going to take years to develop. But if you keep that information in the back of your mind, and you do your work every day with as you kind of look for ways to implement those leadership lessons as I look for ways to implement those leadership lessons that I learned in the past, the dots begin to start to connect. The light bulbs start to go off, and I find myself saying, oh, I learned how to do that, and now I understand how to use it. So don't be discouraged if you feel lost at the time when you're trying to go through a leadership program, or you're trying to go through a management class or something and it just isn't clicking. It will click as you gain the experience to fill out the situation that you need to apply those in. So just soak it in, think about it, put it in your back pocket, and then as you go forward in life, you'll have those tools to pull out and apply to your personal life and your professional life.
Excellent. So let's talk a little bit about what your average day looks like. So what do you do on an average day?
I work at a desk. My average day is a lot of desk work, which I like because living in Minnesota, I don't always want to battle the elements. So I'm happy with being indoors and having an office. I will say though, even if you end up in the same job as I am, you can tailor your daily life to what your preferences are. There is room to go out into the field. So normally I review a lot of construction plans. So I don't like to use paper for that. So I get my construction plans submitted to me for review in PDF format. And I use software like Bluebeam, which is a really good tool. It's a PDF software that's a really good tool for doing reviews and marking up PDFs and sharing it with others. So I use Bluebeam to mark up PDF documents. I read reports. I read the engineering calculations that go into the results that they got. And I think about whether they make sense. I have created my own set of Excel-based calculators, so I can run my own calculations to kind of do a check on the calculations that the project engineer has given to me to see if we come up with the same results, if we're close, or where there might be problems. So that's kind of the land development, stormwater management, construction plan review piece of my job, which takes up a significant portion of my time, especially during parts of the season where there's a lot of construction going on. Right now, winter is coming, the summer construction season is wrapping up, so there's not a lot of designs going on for new construction projects that are going to take place soon. But as soon as we get into winter, design season starts to ramp up because the developers want to have their designs ready to go for the next construction season. So there's kind of a seasonality to my position too, with where development, if you live in Arizona, it might be different, but here in Minnesota, we kind of have design season, construction season, and it goes around in sort of a cycle. Other things that I do, I work directly with consultants. We have meetings, we have Zoom meetings like you and I are having now. And we can share our computer screens. So they will show me, they'll show me their ideas or what they're doing. They'll show me maps. They'll show me all sorts of information that goes into planning these designs, and we can talk about concepts. So I do that a lot with consultants for future projects that are going to be coming up, but they're currently conceptual stage. What else do? I do sometimes go out in the field, especially if I have a question about whether something makes sense. Maybe a plan shows an existing storm sewer or storm inlet or something, and I don't know if it's really there, or I want to see what kind of grate is on it because they modeled it as one thing, and I want to make sure that those assumptions actually make sense. So I'll go out into the field and I'll look around on that construction site and I'll say, yeah, I saw this on the plan, or they missed this, or where they thought was an inlet is actually a covered manhole, so that it's not going to be doing what they thought was going to be doing. So I also look at, I do some work with city-owned infrastructure. So I don't only work with private developments. I do work with the city as its own entity, creating its own projects, public improvement projects, or city infrastructure projects, or what we typically call those. And so I can do some design work on my own. I work in AutoCAD. Civil 3D is the primary software for design work. In the civil field and environmental field follows the civil fields. They're very similar. I do hydraulic and hydrologic modeling. So I model how water flows through pipes and how stormwater, when it hits the ground and becomes runoff, and model what that runoff is going to do as it flows over the ground surface. So I want to know where it's going to be ponding, where it could create a flood issue. I want to know if storm sewer pipes have adequate capacity and at what point they're going to start to fill up, especially in this world of climate change that we're facing, that we're in and also facing. We're thinking about ways to make our infrastructure more resilient and how we can design new infrastructure to handle more water, which is what we're seeing in the climate trends. So I work in modeling programs like XP Swim or HydroCAD, and these are proprietary. High school students probably haven't seen these yet, but they might sound familiar to you as you start to get into college if you go into a hydrology class or a hydraulics class. So I work with a number of different software programs. I do a lot of kind of engineering work at my desk, and I do have the option to go out in the field if I want to. I have a lot of freedom in my job, which I appreciate very much. I think a lot of engineers will find that they have that freedom because it's always a balance of you can model all you want. At some point, you should do some field verifications to make sure that the way you set up your model or the results that you're getting actually make sense in the context of what we're actually seeing out in the real physical environment.
So can you talk a little bit about what the starting pay is for a role like yours, and what kind of advancement opportunities there are for people?
Sure. Yeah. As a first year, if you've taken your fundamentals of engineering exam, you're an engineering intern, or you're an engineering training is what you call is what you're called if you've taken your fundamentals of engineering exam and you're now kind of in the intern apprentice. You're kind of an engineer's apprentice at that point. So when you've got less than a year of experience, you're fresh out of college, you can probably expect to earn somewhere between $40,000 and $50,000. And then as you get more experience and you advance in your career, and you know, 4 or 5 years later, you become a PE, you're probably looking somewhere between the $70,000 and $80,000 range. And then it goes up when if you become a project manager, or you, and all the public, maybe not all of them, but the public government positions, like if you work for the Army Corps of Engineers, or you can be a civilian engineer in the Army, you can do that too. Those salary, the salary progression or the salary tables are public information, so you can Google it. But as you get into like project management and you start, getting higher in your numbers of years, you're looking at well over $100,000 to kind of end your career. If you get really lucky and you end up or you work really hard and you end up in a private consulting firm and you're a partner, and you've gone really far and done a lot of work, and you're probably looking greater than $150,000 easily by the time you're ready to retire. So the prospects are good as an engineer. And as far as job availability, in my experience here in Minnesota, with I've worked for 3 employers in Minnesota, all as an engineer. And what I found is that those employers have been looking for qualified engineers to fill positions, and they haven't been able to find them. So the job prospects are really good for young engineers too. You're likely to find a job, and you're likely to make good money.
Excellent. So just to kind of wrap up, if someone wanted to contact you, how would they go about doing it?
Sure, you can email me. Email is probably the best way to contact me. I can give you my work email address here at the City of Rochester. You can contact me that way. Do you want me to just kind of spell it out?
Yep.
Or
it would be great if you did. Yeah.
Sure, absolutely. Yep. So my name is Lindsey Bartolomei, and my email address is my first initial and last name. So it's LBARTOLOMEI at rochestermn.edu.